Good morning, class. Today we're going to be talking about testing. And testing is a very important aspect of software development. You've probably done a lot of development where you've written your project, you think you've got everything covered, you turn it in and you find out you missed something. That's really where testing is intended to help us out. So let's go ahead and flip to our starter project. This is a very simple game. It's a phrase guessing game, so kind of like Wheel of Fortune or Hangman. And it's basically draws us a lobster pot, and if we make wrong guesses, we end up drawing more of a lobster, and when the entire lobster is drawn, then we've lost the game. So for example, we have a phrase up here. Let's guess. Our first one's A, E, I, O, and U, and you can see some of those were correct guesses, and it fills in that secret phrase that we're trying to guess. The ones that were wrong end up drawing more of the lobster, and if we make too many wrong guesses, we'll eventually draw the entire lobster. So that kind of testing, where you run your program, you put some input in, you see what it comes out, we sometimes call that ad hoc testing, and that's a very normal part of development. But as you've probably come to realize, that style of ad hoc testing is not enough to guarantee that your program is doing what it's supposed to do. And that's where we come into formal testing. So formal testing is where we actually sit down and think about what exactly do we need to do to ensure that our program is doing what it's supposed to do. And there's really two different forms of formal testing. There is formal testing where we actually write up a document called a test plan, and we try everything in the test plan. Basically, every time we want to release our software, we go through that test plan one test at a time and do it. So that's kind of the evolution of ad hoc testing, but instead of just doing what you think of at the moment, you actually have a clear document spelling out every single test you want to do. That's a very time-consuming approach, as you might imagine. So one of the other approaches we've developed over the years as software developers is what we call automated software testing, where we use software to test our software. So we create a test program or a test suite that runs against our software and checks it against expectations. And that's what we're going to do today. Is we're going to do a very specific kind of automated test called a unit test. And the whole idea behind a unit test is we pick a particular unit of code and we test that unit in isolation. And the unit we're going to start with is this game logic class, which actually controls how the game progresses. So you can see in here, we've got the secret phrase, we've got the revealed phrase. As far as its public API, it will tell us what our current revealed phrase is, the number of wrong guesses that we have made, and if the game is won, so if you've won the game, or if you've lost the game, or if the game is still ongoing. And then it's going to have a constructor that takes in that secret phrase that sets everything up, and a guess method which performs guesses. Now, I'm not going to walk you through the logic of this program. If you want to, you can dig through it on your own. But the important thing here is we're testing the functionality. We're not actually concerned as much with the logic of the program at this point. And that's one of the cool things about writing unit tests is you just need to know the public interface of the class. So the stuff that you would normally publish in your UML class diagram, you don't really need to know the nitty-gritty details in order to write good tests. Now, to fix problems your tests show up, then we might have to get in and make some changes. So the first thing we're going to do is create a test project. And so we're going to come into Visual Studio Solution Explorer. We're going to pick a new project. And the kind of test project we are going to be using in this semester is called an XUnit test project. Now, in previous semesters, you may have used InUnit, which is the other popular testing framework for .NET. XUnit is the newer one. It's what Microsoft is migrating to, so that's what we're going to use in this class. And we'll go ahead and name this Lobster Pot Test Project. And that's kind of the convention that we usually stick with is one test project tests a project in our solution, and we give it the same name plus test project to say that it's to test that specific project. And we're going to use .NET 6.0. Now, because we're testing the Lobster Pot project here, we'll also need to add that as a dependency so that it can actually use the code out of the Lobster Pot project. So we'll add a project reference, and we will check that box to say, yes, you can see and utilize the classes in Lobster Pot. Now, you'll notice it gives us a class to start with. This is just part of the boilerplate template called Unit Test 1. We can go ahead and reuse this. Let's name it. And with our unit tests, again, our convention is we name our unit test after the class it's testing. So if we're going to be testing the game logic class, we would have game logic unit test is going to be the name of our unit test file. And we'll go ahead and let it change the name of the class as well. And then it shows us an example of what a fact would look like. Let's go ahead and just delete this and we'll write our own. So before we actually start writing tests, let's just think about what we want to test. So we know that our game logic gives us both the revealed phrase and it holds a secret phrase. And the revealed phrase should be the secret phrase, but all the letters replaced with underscores. So one of the things we might check is that the revealed phrase is the secret phrase with all letters replaced by underscores. And we know that when we make guesses, certain things should happen. So a correct guess should replace all matching letters in the secret phrase or in the revealed phrase. And maybe instead of replace, we'll say reveal. It's replacing them, but we're going to say it's revealing them because that's what it looks like to the player. And then we want, anytime we have an incorrect guess, should increment the wrong guesses property. And a guess should appear in the guesses property. Or prior guesses, I think is what we called it. All right, so that's kind of the core functionality we would normally think of that this game should have. So let's go ahead and write a couple tests to tackle all of these. So the first thing we want to do when we're writing these tests is think about how to actually do them. So the revealed phrase, for example, how would we check that the revealed phrase is the exact same phrase we gave it, but replaced with underscores? Well, we know that our game logic class, for example, takes in its constructor the secret phrase, and that's where it does all that replacement for us. So let's go ahead and take advantage of that. We're going to write a method, public. All of our test methods have a void return type in XUnit. And rather than you using a really long name here, let's go ahead and just give it a very short one. Revealed phrase uses okay, it's longer than I wanted, but that's all right. Matches a secret phrase. And because we want to be able to say what the revealed and the secret phrase should be, let's just do is correct. That's nice and short. Revealed phrase is correct. And in order to test this, it would be helpful to have the secret phrase and what we expect the revealed phrase to be. Okay, so now inside of our method, we can create an instance of the lobster pot. And notice that that's not showing up. That's because we don't have the lobster pot using statement. And because we're using C#10, we can actually use these global usings. And the convention is you put that in usings.cs. It makes sense to do it here because we're going to need this in pretty much every test class we write. So this is lobster pot game is the namespace that those exist in. We jump back to our unit test. Now it says, oh, I know what a lobster pot is now. And when we construct that lobster pot, it needs, or actually not the lobster pot, we want the game logic. And I'm going to use a shorthand constructor where we don't actually have to spell out new game logic. We can just give it a parenthetical, and it wants the secret, which we'll just pass in the secret phrase that we have here. And then we want to do an assertion, is usually the end goal of any test. Assert that something about the state of the object that we care about is what we expect it to be. And we can do an equality check. We expect that our revealed phrase that we are expecting is going to match the game logic's revealed phrase. So what the game logic thinks the revealed phrase should be should match what we expect it to be. And we supply that by making this a theory and providing inline data. And the inline data is a parameter, takes a parameter list which matches these parameters in our method. So the first value we're passing in is going to be our secret phrase. And the second is going to be what we expect the revealed phrase to be. So we basically hard code in some expectations. So here's a very simple one. If we give it the string foo, we'd expect 3 underscores. And let's do another one. And this time, I'm going to do some capitalization, and I'm going to include a space. 1, 2, 3. And we'd expect a space to match the space between foo and bar, because that is a common convention of games like this. You don't count the spaces, you don't count the punctuation. Which actually brings us to another one. Let's go ahead and do one with punctuation as well. All right. And finally, because this is a method, let's go ahead and document it, which we already had our revealed phrase description there. So that's a really easy thing to just drop it in our summary. And notice too that when I added that extra dash in front of it, it actually auto dropped it in the summary for me. So that makes it even easier. And then the secret supplied to the game logic. And the expected revealed phrase. Okay, let's save that. Now at this point we can go ahead and go to our test menu and run. We only have one test, but let's go ahead and run it and see what our results are. And if we go to our test explorer, notice we have 2 passing and 1 failing. So let's see which ones are failing, which ones are passing. So we have to drill down, we get to the revealed phrase, and we can actually pull these open a little bit. And this is part of why it's helpful to have these be short names, because it gets hard to read them after a while. If they're stretching way out here, we have to really resize our window. But you can see foo bar with capitals and the spaces works. It reveals exactly what we expect. And foo did the 3 underscores like we expected. However, foo comma bar did not match our expectation of 3 underscores, the comma, space, and 3 underscores. That assertion failed. And notice that it also gives us a little message telling us where that failed. It failed at position 3. So the third character, it was expecting a comma, but it didn't get that comma. And that means that clearly we have some errors in our logic in that game logic class. So let's go back and look at how we're generating that secret phrase. And notice that as we pull in our go to the constructor. So when we bring in our secret, we create 2 character arrays of length that's equal to the secret string length. And then we populate that by iterating over the secret and copying in the characters directly into the secret phrase. So that's a 1-to-1 match. But here we're checking to see if the secret phrase's character equals a space. And if it does, we go ahead and copy the space in, but otherwise we put in an underscore. Well, there's our problem. Punctuation is not a space, so this is failing. So how can we actually find what we really want to? Well, if we jump into the documentation for C#. If we go to and I'm just doing a quick search, but is letter. I actually know what I'm looking for. The char.isLetter method will return whether or not a specified Unicode character is categorized as a letter. And here's even an example of using it. You use char.isLetter, so this is a static method. This is one of those class methods we talked about. And it will tell us whether or not this is a letter character. And if it's not, like in this case, an 8 is not a letter, so it's going to give us a false. Well, that's a really easy way to do this. So let's go back and rewrite our if statement. So if that char.isLetter of the secret phrase, and then we'll go ahead and write. So this should return a Boolean value and missing a print. There we go. All right, so that was a real quick fix. Let's see if that fixed our problem. So we'll save, run our tests again. And notice that now all 3 of them are failing. And if we look at what the expected and actual values are, so if we expand this out just a little bit more, you can see that we're expecting the blanks, but we get foo_bar. And we expect foo, but we get all spaces. We expect foo_bar. What's going on? It's pretty obvious. We're doing it backwards. So if we go back to our game logic, we can see that, sure enough, if it is a letter, we are copying the letter across. So we actually want the opposite of this. So we could flip our if and else, or we can just put the bang, the exclamation point in front of char to negate that Boolean to flip its value. And this is kind of the value of these automated tests, is it very quickly helps us figure out what we did wrong when we make a change. And this process of making changes and then running our test again, this is called regression testing. It helps us identify if our change is breaking something that previously worked. Like 2 of those tests passed, we made a change. Now none of them passed, that was a problem. Went back and we fixed that, and now they're all working. Let's go back to our tests, and let's tackle our next one. Correct guess should reveal all matching letters in the revealed phrase. And for this one, we could, let's go ahead and do a theory again. And let's go ahead and write our method first. Public void, just call it revealed letters work. And what do we need? Well, we'll probably want to set our secret phrase again. And we probably could just do the same thing where we have revealed. But then we also need to guess a character. So we're going to basically just make one guess and expect that it should be there. Actually, you know what? Let's do a little bit different. Let's do character array of guesses. So we're going to do a little bit more advanced test here. And again, we'll create our game logic. And then we're going to make our guesses for each. Game logic, guess that letter. And then once we've done that, we'll check that our revealed expectations matches what we expect it to reveal. So again, we're going to hard code what these look like. And I'm just going to use the same phrase. So if we guess we need a character array here, and we can use this inline definition to get one. And then we will expect that we should have f and 2 underscores. We'll do the same thing. And let's guess both f and o. We'd expect it to reveal everything at that point. And let's modify this a little bit. So we'll also check for if we give it a guess that doesn't match. At G, we would expect that we only get the 3 underscores, so it doesn't make a change. That allows us to test a couple things at one time. And let's test one where we give 1 correct and 1 wrong. All right, so that's a few options there. Let's run our Test Explorer again. And we have some build errors, so I missed something. Let's look at our error list. Do not convert game logic into char. Oh, this should be guess, not game logic. I don't want to run it. I want to run our tests. There we go. So do our revealed letters work? They all pass. So it looks like we actually had that piece working correctly. So we don't need to make any changes to our code for that. And we can expand these out. We could add additional guesses and answers, but you can kind of see the pattern of how we do that. Incorrect guess should increment the wrong guesses. We could actually do something very, very similar here. So every wrong guess should increment the guesses. We could go ahead and do a theory for this one too. Let's do a char array of guesses again. And what we expect that wrong guesses to be. And the logic for this one's going to be almost exactly the same, so I am going to copy paste this guy down here. So we're just going to make guesses until we've run through the array, and actually we could even do, let's do a for loop actually. I equals 0, I equal to less than plus, and then we'll make our guesses. And actually, I'm going to start this at 1. And as long as we are less than guesses length, that way I can also assert that I, which is now going to start at 1 after our first wrong guess, is the same as the wrong guesses in our game logic. So basically, every time we make a guess, it should be wrong, and we count, is it wrong? and therefore we don't need to have this last argument. You can just use the guesses and the secret phrase as a way of setting up what that should look like. In fact, let's make this a fact, because I haven't done any facts yet, and it should be pretty much the same. Difference is going to be, instead of just do that, we'll declare a secret phrase, which is secret, and character array guesses. It's going to be a new character array, and we'll give it A is not in secret, F is not in secret, G is not in secret. So with a fact, we don't actually supply any arguments. The logic is self-contained in the test. And usually these are fairly simple. This is actually probably about as complex of logic as we'd want to put into a test. But the logic is pretty clear, I think, to anybody who reads it. Or the other way we could have done this is we could have just hard-coded, rather than having a guesses array and doing a loop. We could just say GL guess A, check that it's 1. GL guess B, check that it's 1. That's actually a much cleaner approach, because then there's not a lot of logic for somebody to parse through and understand. You can just read it and immediately see what it is. Now, as programmers, sometimes we chafe at that. We kind of like these more complex solutions, like using for loops and things like that. But let's go ahead and do it that way. But the benefit is this makes your test extremely readable. So anybody who reads it will immediately see what it is. So we'll unroll this loop. And we would expect that this is going to have 1 wrong guess. And if we guess and we might go ahead and check that it's actually empty to start with. We have 0 wrong guesses when we first start. Okay, and with a fact, we have no inline data, and we have no parameters, so that's pretty straightforward. And I forgot to comment this guy, so let's go ahead and comment him now. The secret phrase. Guesses to make. Revealed phrase. And finally, a guess should appear in the prior guesses property. So once we make a guess, it should be in that array of prior guesses. And we'll go ahead and make this one a fact. So we would need to take care for our guess and a care array for our prior guesses. Again, we'll create our game logic. And I'm just going to hard code in a secret phrase here. We could have passed it in as an argument, but it's not strictly necessary in this case. And we want to make a guess for each one of those characters coming in. Or actually, we're guessing the character we supplied. So just gl.guess of the guess, and we would expect that prior guesses contains that. There are a couple different ways we can do this. Probably contains is going to be the easiest. So there is an assert.contains, which searches actually there's several varieties of that, Notice there's one where it looks for a substring in a string, but we're actually interested in the IEnumerable, where we're looking for an item that matches, and we're expecting, we can look for the expected in a collection of the same type. So we would want to check that the guess character exists in prior guesses. Actually, no, we don't even need prior guesses then. We can just do it this way. Yeah, let's do that. GL.prior, or previous guesses. This should be previous. And we don't even need this character right at that point. We can just check to see that a character appears in there. And this can be a theory. And I'm going to go ahead and check both characters that are in and characters that are not in our secret phrase. And if we go ahead and run our tests again, hopefully that one will pass as well. Okay, that works. So we've written all of our core tests, but now we really want to make sure that we're not just testing what we really expect to happen, but also look for those weird edge cases where somebody does something we don't expect and that we appropriately deal with that. For example, what happens if somebody guesses, say, a weird character like a semicolon? Let's just add that one in here. Just out of curiosity. And it worked. Which means the semicolon's showing up in our wrong guesses array, which is not what we want, because we don't want people to guess anything but letters. Our guesses should only be letters, so we're not handling a particular case. So that means we need to deal with that. Should be processed as guesses. So if we give it a character that is not a letter, what should we do? Well, we shouldn't increment the wrong guesses, and we shouldn't add it to the prior guesses. That's an easy one. Or we could have it throw an exception saying that's not a letter. That's another potential way of doing it. It really comes down to what our expectation is. I would probably err on the side of not throwing an exception, just quietly not advancing the game if it's something that should not be allowed. So and if we take a guess that is a bad guess, call it an invalid guess, we would expect that the does not contain, so the opposite of what we just did. So our previous guesses does not contain our invalid guess, and also that our wrong guesses does not change. So it has a value of 0. And because this is a theory, we need to tell it it's a theory, supply some inline data. What are some wrong guesses? Well, a space should be a wrong guess. Any kind of punctuation should be a wrong guess. Like our semicolon we did previously. We should also maybe a tab character. And we should be able to remove this one. Let's just put in capital because we didn't have any capitals there. If we run our test explorer again, and notice our only letter guesses is failing as we expect because we are treating those as valid guesses. So this means we have to go back to our game logic and address that in our guess. In our guess method, we basically want to check, first of all, that that character is a valid character. And we already talked about one way of doing that. So we can do an if and check that char.isLetter. And if it's not that, we just immediately return from this method. And now if we look at this, we have a return value, true if the guess is correct, false if it's not. So we are actually returning something, so we would either have to return true or false here, and it doesn't make sense to do either because that is not a match. So this is actually a good use case for throwing an exception. And that would be an argument exception, and we say guess must be a letter. And isLetter starts with a capital I. There we go. All right, so now we are throwing an exception, so we need to add a exception. An example, exception. If guess is not a letter, and if we come back to our game logic, we're going to change our test. Game logic unit test, there we go. We're going to change this to, rather than checking for these things, we're going to assert that we're going to throw the error. We do this with assert.throws, and then we tell it what kind of exception we expect. And it takes an action, which is a lambda, so the same lambda syntax we talked about before, that in this case just does the thing that's going to cause the error to occur, the exception to be thrown. And we run our test explorer again. Notice that now it's passing. But if we actually run our game and we were to put in one of those characters, because we didn't account for that in our design, it will actually crash our program. So if we go back to our lobster pot, when we test that, that's one of the things we need to deal with, is it needs to accept the possibility that that guess is going to cause an error. You can see here that we have this if statement we're checking, and that's where the true and false comes in, is we're printing different things based on that. So we could go ahead and surround this with a try catch. We'll catch the exception. That is caused if that is not a valid character. And then we can console to the must guess a letter. And that should take care of that problem for us. Now if we run our program, we try guessing some punctuation, it'll tell us you must guess a letter. Do anything that's not, so I'm typing lots of different random characters, it's telling us that you have to guess a letter. We also can't do numbers. Okay, so that's really kind of the ideas behind writing tests, is that we want to think not just about what is the proper behavior, but also what is the edge behavior. So this is one piece of edge behavior. Another piece of edge behavior is, should you be able to make the same guess twice? Probably not. So the same thing, we can go ahead and say, yeah, it basically should be public void only guess once. And let's do this one as a fact. So we'll make our first guess for the character A, and GL or assert.throws and let's make this effect. So we'll use the same mechanism that it should throw, that's not a valid guess, the second time we try to make that invalid guess. And we did character A, so let's do character A again. And if we go back to our tests, run that one again, only guess once, should be failing at this point because we haven't actually made sure that that's the case in our logic. So if we go back to our game logic, we also want to make sure that the character that is being guessed is not in our prior guesses. Previous guesses. Cannot guess the same letter twice. So now we have two different cases where we would throw that exception. And notice that we're supplying a message to that argument exception. So if we jump back to our lobster pot game, rather than writing out you must guess a letter, which is not necessarily what the problem was, we can actually just use that e.message and print that directly to the console. So if we guess something that's not a character, like I'm going to do a semicolon, it tells us you must guess a letter. If we guess A, and then we guess A again, it says you cannot guess the same letter twice. So we get that message printing out correctly either way. And now if we run our tests, they should all be passing. So that's some of the basic ideas behind unit testing. We're going to come back and talk about using mock objects when we start having dependencies in a further testing exercise. But for now, this is a good starting place where we've completely tested one unit of code. So go back and make sure that you finish commenting all of those tests, because there's a couple that we skipped commenting on. Get that all filled out and go ahead and create a release and submit it. And that's what our exercise is. And I will see you guys.